Record. Okay, so, oh wait, you guys don't see anything. There she is. All right, so guys, what do we got here? Again, it's not about the rule, right? It's not about the rule. You get the rule from yesterday, I hope, and that rule was what? If I gave you this, and I said find the derivative of this would be what? Take the 3, multiply it by the 5, and do what to the exponent? Subtract 1, right? So that, again, that's the rule, and I think we can all agree that that's not a problem, okay? It's when we get, again, something like this, right? Talk to me about how we can rewrite this in a way that allows me to use the rule. Give me some ideas.
5/3.
All right, so Evan wants to go 5/3
times x to the negative pi.
times x to the negative pi. I would agree. I think that's a good way to rewrite that. So he just kind of wanted to bring this up top because we haven't talked about how to like really deal with things in the bottom of a fraction yet. Okay. Now what? Am I good? Can I just take the derivative? Yeah. So our derivative would be, all right, so I'm going to take this negative pi and multiply it by the 5/3, right? So it's going to be negative 5 pi over 3 x, right? And then what am I supposed to do to the exponent? Subtract 1. And that's literally how I would have to leave it, right? All right, so again, the key to that is being able to rewrite it, right? Okay. I would call this 6 times x2. Okay, now again, where's the variables? In the denominator. So if I'm going to rewrite it like this, they're going to become negative now, right? So I'm taking the 5th root of x cubed, right? So it's going to be negative 3/5, right? Negative 3/5. And our derivative? So I'm going to write it as dy dx this time. No particular reason, just doing it because I want to. So negative 3/5 times 6 is negative 18/5. X to the negative 3/5 minus 1 is negative 8/5. And again, probably not going to see your answer left like that, right? Going to see it left like this. Right? They're not going to leave this negative exponent, right? They're going to rewrite it like that. They're going to put it back like that. Is that okay? All right, so what are some of the things we're going to do with this, guys? Right there, we all agree, and I think we're mature enough now to understand that the AP exam isn't going to put one of these on there and say find the derivative, right? I mean, we're doing things with these derivatives, okay? And here we have our first example of us doing some things, and some of the things we can do and how we put some problems together in pieces, okay? So here I give you a function, and there are 3 things I want you to do with this function. The first is I want to find the value of the derivative at negative 1. So you have a number of ways to do that now. One way is like what we did last class. Use the limit definition at that point. Agreed? No problem. What's another way to do it? Just take the derivative and plug in negative 1. If I have a calculator and I'm allowed to use a calculator, I can use a calculator to do it, right? So we have a multitude of ways to answer this now. So what is our derivative? Well, our original function can be rewritten as a half of x to the 4th, right? Which means our derivative is going to be what? 2x to the 3rd. Very good. So our derivative at negative 1, What's negative 1 cubed? Negative 1. Good. So this is negative 2. And our derivative at 0 is 0. What is part C? Find the x-coordinate where this has a slope of 128. So guys, do you agree that the output here is the slope of the tangent? Right? The input is the value or the x-coordinate, right? So what do I want to do? I want to figure out where this function as a derivative equals 128, right? Where's the derivative equal to 128? Because that's going to give me the slope, right? So it's a half. Thank you. Half of x to the fourth equals 128. Multiply both sides by 2.
Can you use the derivative that we just found at 2x?
Oh, shoot. Yeah, I'm sorry. I wrote the wrong one.
No,
Yeah.
it's okay. I was just confused.
Well, yeah. Well, you're confused because I wrote the wrong one. The derivative's 2x cubed, right? So divide by 2. X cubed equals 64, and the cubed root of 64 is 4. Good?
You would still get the same answer if you did it with 1/2 x to the 4th.
No, 1/2 x to the fourth was just the original rewritten.
Okay.
Right?
Yeah.
This was the
Oh.
derivative.
Okay.
Yeah. Guys, if I set the original equal to 128, what would that tell me? What the point on the graph is, right? At 128 as a y value, right? This gives me the slope of the curve at what? X equals 4, and what is it? 128. Cool? All right. Actually, let's make sure it's cool. I really want to make sure this concept makes sense because like this is the very basis of a lot of the questions that we're going to be asking throughout the year, okay? It's not a matter of what to do, it's when to do it that oftentimes people are going to struggle with, okay? I know what to do, it's just I don't know when to do it, right? So again, what was the original function? It was a x to the fourth over 2. X to the fourth over 2. All right, so there's this, right? So what we just did, guys, is we set the derivative equal to 128, right? So in other words, somewhere along this curve, there's a slope of 128. Well, this is saying that that's happening at 4. So yesterday we said that we can find a derivative at a value of 4. I just typed in a 4, and it brings me right there to 128. So what that means is the slope of the tangent is 128 at 4, right? That's just what we solved. Cool? All right. All right, so guys, this is the type of question that is very, very like common on an AP exam. All right, and it's used in a number of different ways. But find the equation of the tangent line. I give you a curve, give me the equation of the tangent, okay? So what do I need to do in order to solve this? I need to use the point slope formula, yes? Right? So I need to use y minus y1 equals x times x minus x1. What do I need to plug into this? I need to plug in the point of tangency as my x1, y1, and the slope of my tangent as my m. Point of tangency is going to be what? The point on the curve that the tangent line goes through, right? So do I know what that point is right now? Oh, I know a part of it. I know that the x value of that is what? -2, right? All right, so if I want to figure out where I'm at, I'm going to plug -2 in. So f of -2 is this, or 12, right? So there's a point on this curve at -2, 12. So there's my x1, y1. Okay. What do I want to know now? I want to know the slope of my tangent, right? Well, how am I going to find the slope of the tangent? Take the derivative and plug in the value of x that I'm interested in, right? Okay, so my derivative is what? What's the derivative of 3x squared? 6x. All right, and what is the slope of the tangent at -2? It's -12. All right, so now we have everything that we need. And so our final answer is going to be y minus 12 equals -12 times x plus 2, because it's minus negative, right? Guys, to do the equation of the normal line, all I got to do is one thing. What is a normal line again? Perpendicular to a tangent, right? So the only thing I need to do is change that -12 to be what? Positive 1/12. Yep. Find the points where the normal line intersects the graph. Guys, what does that mean? Well, isn't my original curve a parabola? And isn't my normal line one that's perpendicular to a tangent, so it's going to go through it twice, right? Because a tangent line is going to look, so if this is my parabola, if I have a tangent here, right, then the normal line is going to do what? It's going to do that and go through it twice, right? So we want to figure out where that happens. Well, if this is my normal line, and I want to know where does it intersect 3x squared, what am I going to do? Well, guys, 3x squared is a value of f of x, and f of x is the same as y. So I'm just going to take this and substitute it in. Distribute the 1/12. I get that. A 12th of x plus 2/12 is 1/6, right? This kind of sucks, doesn't it? Like all these fractions and stuff in here. How can I get rid of them all? I don't like fractions. If I multiply everything by what? By 12, right? Then all the fractions are going to go away, right? So in other words, if I do this, that cool? Now what? Move everything, yeah, move it over, right? Create a quadratic, right? So it's going to wind up being that, right? And then here's the thing, guys. I'm going to stop, right? And this is like the moment where I presume that you can do one of two things. Maybe you can factor it. Maybe you can use the quadratic formula. Maybe you can complete the square. Maybe you can do something to finish that, get values of x, and find points of intersection. Can we all agree that that's a skill that you should be able to do? Great. All right, let's go down here. Guys, here's the thing, right? And I think you're already getting like the idea that I can't take derivatives until I get them looking like power functions, right? So here I give you a bunch of different things. And notice how I write this. I write d over dx. What does that mean? D means do, right? D means do. So I'm going to do derivatives. So I got to change these all around. And Evan already kind of got us going on this by rewriting these, sometimes making negative exponents, etc., right? So would we agree that in this first one, I want to do a derivative, right? And I'm going to rewrite this as 5/2 and x to the negative radical 2. All right, so again, I want to have this all as one line. I don't want to have a fraction per se, right? Now am I good to use the power rule? Yeah, right? And so take this radical, multiply it by that value in front, and then that's going to be to the negative radical 2 minus 1. And again, that's literally how I would leave that, right? Because there's no way to subtract those. Now, what's one thing I could see? Well, maybe they could rewrite that and put those exponents on the bottom. Could see that. What do I got to do first here? I got a little math I can do down there, right? Yeah, so do it. All right, well, we can make it look a little nicer. By doing that, right? And now taking a derivative is going to be pretty easy. Derivative, negative 3 over 2, x to the negative 4. But again, am I gonna see the answer like that? What's wrong with my answer? The negative exponent, right? You're not going to see that, guys. I mean, you're never going to see that written. You're going to wind up seeing. You're going to see this, no doubt. Okay, no doubt about it. This is a good one. What's the exponent on this t? 1. And what's this? The same as t to the 1. Well, t to the 1/2, right? It's in the bottom right now. No, that's 3 times. That's not the third root. That's 3 times, right? So this is t to the 1/2. So if I was to rewrite this, this is 7t to the 1st over 3t to the 1/2, right? I mean, that's really what I would write if I had numeric exponents, right? So how do you divide these? What do you do with them? If this was t to the 5th and this was t squared, what would you have? T to the 3rd, right? Yeah, you would subtract the exponents, right? So what's 1 minus 1/2? T to the 1/2. Where does the 1/2 go, on the top or the bottom? Where's there more? Yeah, on the top, there's more, right? So it would be the same as this. And now we can take our derivative, right? So it's going to be 1/2 times 7/3. And then subtract 1/2. I'm sorry, subtract 1 from the 1/2, right? So there's my derivative. But again, not going to see it written like that, are we? Going to see it written like that. Gould, is the power rule hard? Not at all, right? It's the other crap. I mean, it's the other stuff. It ain't the calculus. Power rule's a piece of cake. Okay, how about here? Guys, this whole thing is in a negative exponent, right? If this whole thing is a negative exponent, to make it positive, I have to bring this whole thing to the top, right? So this is the same as the same as that, right? That has to go to the top of the fraction, B, right? So 3m squared is the same as 3m squared. 9m squared. So that's the same as 54m squared. All right, and if we take a derivative of that, 108m. Good? So again, the calculus, cake. The rest of it, hard, okay? Guys, guess what? You know how you could do limits in succession? If I have 3 pieces, you could take the limit of the first piece, add it to the limit of the second piece, subtract it from the limit of the third piece, and get your answer. Same thing with this, right? So, Lex, if I want to take this derivative, all I got to do is take the derivative of this first piece and the second piece and the third piece. That's it. So f prime of x is, what's the derivative of x cubed? 3x squared. What's the derivative of negative 4x? Isn't that just a line? What's the slope of that line? Negative 4, right? So it's always the number in front, right? And what's the derivative of any constant? 0. And so that's our derivative. Exactly. That's exactly right. You just do it to each piece. So Brandon, that's a half, right? Or negative a half. So 4 times negative a half is sine negative 2. X to what power now? Okay, what's the next piece? 6x squared. And what's the derivative of a line? It's the slope, right? Minus 5. What makes this one hard? Yeah, it looks nothing like what we've done, right? But what am I going to do? I'm going to take, check it out. I'm going to take this piece and divide it into that, and then divide it into that, and then divide it into that, and then divide it into that. So again, I'm rewriting because I'm going to rewrite it, right? Again, this is not going to be the calculus. It's going to be the algebra that's hard. So what do I have? I have 2 divided by 2. So that's a 1, right? And then I have x cubed divided by x to the half. What's 3 minus a half? 2.5. 2.5 is the same as 5 over 2? Yeah. All right, so there's my first piece rewritten. Minus 3/2. What's x squared divided by x to the 1/2? Well, what's 2 minus a half? All right, I'm going to wait. You guys are doing it. You guys are doing it. I can see you're doing it. You want to see if you can do it. Go ahead. Try to do it. You're busy little beavers. You're like, oh, I think I can do it. So what I have on the board right now is the original rewritten as single terms with exponents not in the denominator of the fraction, right? So what am I doing here? I'm doing 3 minus a half. I'm doing 2 minus a half. I'm doing 1 minus a half. And because this is on the bottom, it's x to the negative 1/2 for that, right? So now I can take my derivative. So I bring the 5/2 in front. So what do I have? I have 5/2 x. What's 5/2 minus 1? 3/2. Okay, minus 3/2 times 3/2 is 9/4. x to the, what's 3 halves minus 1? 1/2. Plus, a half times 7 halves is 7/4. Bless you. A half minus 1 is negative a half. Minus 5 halves times negative a half is negative 5/4. And negative a half minus 1 is negative 3 halves. Which one? This one? Well, it's a half minus 1. This? I don't, should, because it was what? It's negative a half times 5 halves, right? See it? Negative a half times 5 halves makes this minus. All right. Again, is this how we're going to see it written? No, we're going to wind up seeing this. We're going to see 5 and then the square root of x cubed over 2 minus 9 radical x over 4 plus 7 over 4 radical x minus 5 over 4 square root of x cubed. All right, that's the way you're going to see your answer written. All right, so knowing the rules of what? Of radicals, complex radicals, right? Moving exponents up and down, like those are non-negotiables. Got to be able to do those, right? What do I got to do here in D? Yeah, I got to do a bunch of math before I can do anything, right? What do I have to do first? Can I distribute the x first? No, I have to FOIL first, then I have to multiply by x. Actually, what if I do this? Can I do that? So actually, could I have distributed this here? Well, actually, then it wouldn't have been squaring. Yeah, so forget what I was going to say. We'll FOIL first. Right? Derivative? Emily, we saw it yesterday. Taking that pointer stick and moving it along that curve, right? Me moving left to right in the room. What did I say about velocity? When I changed direction, it had to be what? Zeros, right? Had to be 0, right? Velocity has to be 0 when you're changing direction, because when you're moving left, it's negative. When you're moving right, it's positive, right? Well, guys, it's the same thing in calculus. Any what? Any maximum or any minimum has a turning point, doesn't it? Well, it's kind of the same way. It's not really a velocity now, but it's what? It's a derivative having to equal 0 at those turning points. So one of the most powerful applications for derivatives is being able to find horizontal tangents, right? Because guys, if I can find a horizontal tangent, if I can find a, if I can find a horizontal tangent, then that's where the slope had to equal 0. And if I know where the slope equaled 0, then I have a maximum or minimum of the curve, right? So that's really powerful. Okay? Yatin, I want to make sure you got this, because this is what I'm saying. I'm saying that if I have this function, right, I would have a horizontal tangent here, right? I would have a horizontal tangent here, right? I would have a horizontal tangent here. I would have a horizontal tangent. This stinks. I would have another one over there. Right there, right? And again, just to make sure we know why. Why, guys? Because what is the slope of the curve right here at this point? Give me a word.
0.
At this point.
Positive.
Positive. Okay, where my finger is, okay, guys? How about here? Still positive? Still positive. Well, what happens? It eventually turns to be what? To be negative, so it had to what? It had to hit 0, right? And then it comes down here, Yateen, right? And then it gets here and it turns, so it had to be what? It had to be 0, and then it comes here and then it turns, so it had to be what? We get it, guys, right? So these tangents that are being drawn have to be 0 if I went from what? From a positive slope to a negative slope, or a negative slope to a positive slope. Makes sense. Okay? So if I give you this curve, right? And I ask you, this is the original function. I say, where does that function have horizontal tangents? Well, it's where the derivative equals 0, right, isn't it? It's where the derivative had a slope of 0. So in this case, I'm going to find my derivative. What's my derivative going to be?
4x cubed.
Agreed? And I want to know where that equals 0. So I'm going to take out a 4x. Factor. And I have solutions of 0 and positive or negative 1. Ugh, sorry. Did I finish? Did I really answer the question though? Did I answer the question? No, because what do I really want to know? I really want to know what the coordinates of the turning points are, right? So now I have to do what? Take these values and plug them back in, right? And so into the original equation, right? Because the original equation tells me where I am, right? Where I am. So you have, let's see, so if I plug in 0, I'm going to get 2. Do you guys agree with that? Vertex, or I'm sorry, y-intercept. Plug in 1, and I get 1. Plug in negative 1, and I get 1. Right, so those are our points. Brandon, I'm going to bring you back for a minute to pre-calc. Do you guys remember when you did end behavior? The limit as x goes to infinity, the limit as x goes to negative infinity, right? What did you do? You looked at this thing right here, didn't you? It's x to the 4th, right? So what do you know about this curve? You know that it continues to go up and up, right? Okay. Do you agree that given enough time, you guys could find the roots? Okay. So let's just suppose this had a root here and here. Okay. Let's just pretend. All right. And what did your teachers... Actually, let's suppose it has 2 more. Because I know it has 1 here. Let's put 1 here. And what did your teachers say? They said play a game of connect the dots, right? And so you went down, and then you went through here, and then you went through here, and then you went like this, and you finished it up, right? And then you said, okay, that's your graph, right? And then your teachers would say, or the question in the class would be, well, where do I put these things? And your teacher would say, well, right now you just kind of like, you would have to plug in values to get those points, right? Well, guess what we just did? No, we just figured out what these points are. Didn't we? We just figured out what these points are. we know what these peaks are. We know how high it goes, right? And that's pretty powerful. Okay, so we can graph a curve really efficiently using this. Okay? Well, and we're going to do a lot of that. We're going to do a lot of that. All right, so we know that a function has point of tangency. So if I was to draw this out really quickly and say here is f of x, and here is a value of c, okay? Here's what this is saying, guys. It's saying if I was to draw in my tangent line, and we were to call this tangent line t of x, what does t of x share with f of x? Well, they share the what? They share the y value. They share whatever this point is, right? So they share c comma f of c, or c comma t of c, right? In other words, to get the y value, I can plug the value of c into the original function or into the tangent. Fair to say? What else do they share? Well, they share the same slope at that point, don't they? So they both share those two commonalities, okay? So we're going to use that to answer this question now, okay? We're going to use that to answer this question. This is an adaptation of an old AP question, okay? This is right off an old AP. Here's what we got. We want to find the value or values of k so that this line is tangent to this curve, okay? So we have some curve, we have some parabola, right? Definitely a parabola. And I want to know what value of k makes this the tangent. Cool? All right. First thing I want to do is I want to figure out, well, what is the slope of this tangent, right? Because I know that it's going to share that with this, correct? All right, let's do that. So I'm going to take this. I'm going to get y alone, right? And I get this, right? So the slope of the tangent is -5. At some value of x. Do we know what the value of x is? No. Okay? So what else do we know? We're looking for the point on this what? On this curve where the slope of the tangent is -5, right? So don't we want this? Don't we want the derivative of this curve to equal -5? Right? That's what we're trying to find. We want the derivative of this curve to equal -5. Do we know what the derivative of this curve is yet? No, but can we figure it out? At least in terms of the x and the k? Yeah. So the derivative is going to be what? What is the derivative of 2x squared? What is the derivative of kx? K, because it's a line, right? With a slope of k. What's the derivative of -1? 0. So I want this to equal what? -5, right? All right. So all the work that, oh, wow. All the work. No. All the work that we just did pertains to the slope of the curve, doesn't it? Okay? Let me move this down here. All right, so this was all work involving the slope. All right, over here, we're going to do all work now involving the y value of interest, right? The y value of interest. Because we know that what? We know that a tangent line and a function always share the same value of y, don't they? They share a common y value. So guys, isn't this equal to this? They got to equal each other, right? Isn't that how I find where two things intersect, right? Well, I got y by itself, and this is the same as y, so don't I just want to take 2x squared plus kx minus 1 and set it equal to this? All right, Brandon, what's that going to do? That's going to tell me where the blue function intersects the green function, right? Now, here's where you guys are going to be a little confused. I did all that work and I know that this has to be true, right? And then I did all that work and I know that this has to be true, right? Well, guys, this is a line with this is an equation with an x and a k, and this is an equation with a x and a k. That's a system, right? So now we got to solve this system.
Why can't you move the 4x to the other side and get that like equal to k?
That's precisely one of the things I'm going to do right now. Yeah. So over. Yeah, you're right on the button. So k equals -5 minus 4x, right? So I'm going to take that and I'm going to bring it. Actually, you know what? Let's make it even easier. I like your idea, but I got a better one. I got a better one. No, we'll go with yours. Forget it. 2x squared plus. This is my value of k now, right? So now I'm going to plug that in here. Times an x minus a 1 equals that. All right, so again, it's kind of ugly, but we're going to distribute the x. I get all that. Going to move everything to one side of this. Is that cool? Because I want to create a quadratic. All right. I'm going to move. Guys, I'm a problematic person. Okay, I like making things as hard as possible. I'm going to move everything to the right, and the reason why is because what? This is going to give me -2x squared, right? So I'm going to move it to the other side just so I can keep my x squareds positive. Or I can negate everything at the end. Either way, doesn't matter. 2x squared. Let's see. Oh, wow. When I add this 5x over here, it's going to what? Cancel. When I add the 1 over here, I'm going to get what? -8 equals 0. Right? So again, that's the algebra, right? That's just the algebra. Take a 2 out. Oh, wow, cool. That's going to be a difference of squares. And so I have x values of positive and -2. Boy, it's a good thing that Emma suggested that we solve for k, because now I can actually get the answer to the question, right? Because the question said at what values of k, so now I got to take this and plug it in over here, right? So values of k are going to be -5 minus 8, which is -13, and -5 plus 8, which is 3. Not 5, 3. And there it is. There is a kind of higher level question that's taking the stuff that we're doing and put it into play, right? All right, one more little bit here, and then we'll quit. couple trig derivatives, guys. You have to memorize these, okay? Star these in your notes. Make a note somewhere that you got to memorize these. All right, got to memorize them. Okay, ready? 2 sine of x plus 7. What's the only thing there that I can take a derivative of? Agreed. I mean, using the power rule, the 7, right? So I have to know how to take the derivative of sine, right? And that's just memorizing the fact that the derivative of sine is cosine. So if I have 2 sine of x, the derivative is going to be 2 cosine of x. And that's a new rule also, guys. When there's a number in front like that, it's just a constant multiplier. You're going to keep it. Okay? Guys, what's the derivative of 7? 0. Yeah, so this is my answer. Okay? Derivative here. What's the derivative of x? It's a line with a slope of 1. And the derivative of cosine, we have to memorize as negative sine of x.
And that's it.
That's it. Cool? All right. Remember I talked about the fact that like nobody gets hundreds on AP exams, right? So this would be an example of nobody gets hundreds on AP exams because you can't answer this question unless you understand and know a trig identity. And the trig identity you have to remember is the following. Hello, Mr. Natali.
Hi. You over the beans?
No,
That's it.
I don't know. I can't. Yeah,
Did you touch it?
he may have.
I need in 10 minutes. I mean, I'd wait.
Yeah, no, I'm not going to go. Trig identities you guys have to remember is this, okay? 2 sine of x cosine of x is equal to sine of 2x. That's one of your trig identities. And Emily's going to prove it. She's going to be like, all right, fine, Picardo, whatever. You want to be like that? I'm going to remember all those trig identities. I'm going to get the 100. Yeah, she's going to go home and study them all. So the way that I'm going to rewrite this, guys, right? The way that I'm going to rewrite this is g of x equals, well, I have 2 sine of x over 2 cosine of x over 2. Looks just like this, right? Except I don't have an x, I have an x over 2, right? So when I use this rule, it's going to be sine of 2 times x over 2, right? Which is just x. And what is the derivative of sine of x? Cosine of x. So all of that for that. What do we got? 5 minutes left? Let's call it a day. Whew. I know you guys are